So we discussed this problem, we discussed this problem, we discussed this problem. We discussed this, we discussed this, we discussed this. We also discussed these problems. By using these 9 problems, we have understood the concept. We have understood the concept, how to use the method of finding the HCF. These 3 problems also we discussed. There was a technical issue in the afternoon, so we discussed total 9 problems. Now 10th problem. 10th problem. Tenth one. Shall we discuss? Shall we discuss the 10th one? Now listen carefully. Before I solve the problem, there are few concepts which we will discuss. Concepts. First concept. HCF of 2 consecutive natural numbers. HCF of 2 consecutive natural numbers. 2 consecutive natural numbers is always 1. First important key point. HCF of 2 consecutive natural numbers is always 1. For example, HCF of 5, 6 is 1 because 5 and 6 are consecutive numbers. HCF of 12, 13 is 1 because these are consecutive numbers. This is the first important key point. Second key point. HCF always takes the lowest power of the HCF always takes the lowest power of the common prime basis. HCF always takes the lowest power of the common prime basis. These 2 important concepts. HCF of 2 consecutive natural numbers is always 1 and HCF always takes the lowest power of the common prime basis. These 2 important key points are used in these problems. HCF always takes the lowest power of the common prime basis and HCF of 2 consecutive natural numbers, it is all 1. Now if you observe, these both are these 6 ones and it is 1, 2, 3, 4, 5, 6. These are nothing but 5 ones ending with 2. These both are 2 consecutive numbers. Additional 1 is written. HCF of A, A plus 1. It is always 1. HCF of consecutive natural numbers is always 1. Answer for this question is 1. Answer for this question is 1. Now if you see, what are the numbers? There are 3 numbers in the 10th question. 25 is 5 square into A into B square into C cube. What is N2? N2 is nothing but 2 power 4 into 5 into A into B cube into C square. What is N3? N3 is nothing but 12 in prime factors 2 square into 3 into A square into B square into C. How to find out if a prime bases are given? How to find out when prime bases are given? HCF is nothing but the HCF always takes the lowest power of the common prime basis. HCF always takes the lowest power of the common prime basis. Lowest power 2 square 2 power 4. Lowest is 2 square from this. 5 power 1 5 power 2. Lowest is 5 power 1. Lowest is 5 power 1. Sorry, here there is 2 power 0. 2 power 0. Here again there is 5 power 0 because this can be written as 2 power 0 and also it can be written as 3 power 0. 2 power 0, 2 power 4, 2 power 2. Lowest is 2 power 0. 5 power 0, 5 power 1, 5 power 2. Lowest is 5 power 0. 3 power 0, 3 power 1. Lowest is 3 power 0. A square. Lowest is A. B square, B cube, B square. In everywhere there is a b square, here there is a b square, here there is a b square, b cube. Lowest is b square. C power 1, C power 2, C power cube. So it is C power cube. So answer for this question is A B square C power 1. HCF always takes the lowest power of the common prime basis. HCF always takes the lowest power of the common prime basis. HCF always takes the lowest power of the common prime basis. HCF always takes the lowest power of the common prime basis. I hope the idea is clear. Question number 11 we used HCF of any two consecutive even numbers. HCF of any two consecutive natural numbers is 1. They both are consecutive natural numbers, so it is 1. Similarly, 2 cube 2 power 4, lowest is 2 cube. 3 square 3 power 4, lowest is 3 square. So HCF answer for this question is 2 cube into 3 square, which is 72. 2 cube into 3 square, which is 72. Two concepts in this question. HCF of any two consecutive natural numbers is 1, and HCF always takes the lowest power of the common prime basis. Ashu, are you facing any voice problem? Is it clear right now, Ashu? Idea clear? HCF always takes the lowest power of the common prime basis. Kindly reply, Ashutosh, is the voice clear right now? Is the voice clear? Are you facing any voice problem? Is it clear? Okay, now next one. Next, elimination approach based problems. Just now we discussed write how to find out the HCF. This entire slide is used. If answer options are given, how to solve. If answer options are given, how to find the HCF. If answer options are given, how to find the HCF. If answer options are given, how to find the HCF. But before we solve these four problems, let me understand a few concepts. We will use that concept and we will try to solve the problem in very less time. Concept. First one, for example, first we will take an example. Suppose if I take HCF of 6, 9. HCF of 6, 9 is nothing but 3. HCF of 6, 9 is nothing but 3. Why? Because lowest is 6. 6 will not divide 9. We will take the factors of 6. The factors of 6 are 1, 2, 3. Highest is nothing but 3. HCF of 6, 9 is 3. Now if you observe carefully, 6 is divisible by 3. 9 is divisible by 3. 3 is also divisible by 3. If I take two numbers which are divisible by 3, HCF of any two numbers which are divisible by 3, answer also will be divisible by 3. HCF of any two numbers which are divisible by k, answer also will be divisible by k. Are you all with me, right, sir? One more example. HCF of 12, 16. 12, 16 is nothing but 4. 12, 16 is nothing but 4. Now if you observe carefully, 12 is divisible by 4. 12 is divisible by 4. This is divisible by 4. 16 also will be divisible by 4. 16 also will be divisible by 4. So if I take two numbers which are divisible by k, HCF in the answer is also divisible by k. If I take answer and one number divisible by k, the remaining number should also be divisible by k. The remaining number should also be divisible by k. Now by using this approach, let us solve the first question. Very beautiful slide, sir, it is. HCF of 420, 1782. Options are 4, 7, 6 or 8. Third one. HCF of even numbers will always be an even number. HCF of even numbers will always be an even number. Fourth one. HCF of odd numbers will always be an odd number. HCF of odd numbers will always be an odd number. HCF of even numbers will always be an even number. HCF of odd numbers will always be odd. HCF of any two numbers which are divisible by k, answer also will be divisible by k. That k could be divisible by 3, divisible by 4, divisible by 5, and so on and so forth. HCF of any two numbers which are divisible by k, answer also will be divisible. Now see here, how am I solving first question? HCF of 420, 1782. These are the option. Option B is eliminated because 7 is an odd number. HCF of two even numbers will always be an even number. 7 is completed. Now see, 420. 20 is the last two digits. Last two digits is divisible by 4. 420 is divisible by 4. Suppose if I take the option as option 1. If I take the option as option 1. 4 is divisible by 4, 420 is divisible by 4. But what is the divisibility rule of 4? Last two digits should be divisible by 4. Last two digits should be divisible by 4. Last two digits should be divisible by 4. Last two digits is 82. 82 is not divisible by 4. So already we discussed, if this is divisible by 4, this is divisible by 4. 1782 should be divisible by 4. 1782 is not divisible by 4. Therefore, my assumption 4 is right is incorrect. 4 is incorrect. If a number is not divisible by 4, how can it be divisible by 8? Because 8 is nothing but 4 into 2. 7 is out because HCF of two even numbers is always an even number. 7 is out. 4 is out. Why? Because 420 is divisible by 4. If answer option A, 4 is divisible by 4. 1782 is not divisible by 4. If a number is not divisible by 4, how can it be divisible by 8? First one answer for this question is 6. Beautiful question by using answer options where we are using the divisibility rule. Same thing I will use it for question number 2. Same thing I will use it for question number 2. If option A is right, this is divisible by 10, this is divisible by 10, this is divisible by 10. 495 is not divisible by 10. That means if three numbers are divisible by 10, answer will be divisible by 10. But one number is not divisible by 10. So option A is out. If first option is not divisible by 10, how can the D option 20 it will come? 20 is a multiple of 10. 20 is a multiple of 10. So 10 is out, 20 is out. Now we are stuck between 15 and 5. 15 is nothing but 5 into 3. 15 is nothing but 5 into 3. Answer should be divisible by 5 and answer should be divisible by 3. Answer, what is the divisibility rule of 3? Divisibility rule of 3 is sum of digits should be divisible by 3. Sum of the digits should be divisible by 3. Sum of the digits should be divisible by 3. 2 plus 1, 3. It is divisible by 3. 4 plus 9, 13 plus 5, 18 is divisible by 3. 980 is not divisible by 3. 980 is not divisible by 3. That means, if it is not divisible by 3, how can it be divisible by 15? Answer for the second question is 5. I hope the idea is clear. Option A is eliminated because if option A is right, all the three numbers should be divisible by 10. But the second number 495 is not divisible by 10. If a number is not divisible by 10, how can it be divisible by 20? 10 is out, 20 is out. 15 is 5 into 3. Number should be divisible by 5 and 3. But the third number 980. 980 is not divisible by 3. Similarly, third one. 1680 and 3600. Now if you see, it is cannot be answer 300 because this is divisible by 100. 3600 is divisible by 100. 1680 is not divisible by 100. So 300 is out. So 300 is out. Now see here. 140. 140 is nothing but 7 into 20. Answer should be divisible by 7. 1680. 7 2s are 14, 280, 7 4s are 28, 40. This is divisible by 7, 140 is divisible by 7. But 3600 is not divisible by 7. So option D is out. Are you all with me? Option A, 180. 180 is nothing but 9 into 20. Answer is divisible by 9. 3600 is divisible by 9. 1680. 1680 should be divisible by 9. What is the divisibility rule of 9? Sum of the digits should be divisible by 9. Sum should be 9. 1680. 1 plus 6, 7. 7 plus 8, 15. 15 digital sum is 6. So it cannot be answer 180. Answer for the third question is 240. I hope all the concepts are clear to you. Answer. We are assuming that something in the answer and we are proving that it cannot be the answer and we are eliminating that answer. Again I am explaining. HCF of 1680, 3600. First option 180 is eliminated. How it is eliminated? 180 is 9 into 20. Answer is divisible by 9. 3600 is divisible by 9. 1680 is not divisible by 9. 140 is 7 into 20. 140 is divisible by 7. 1680 is divisible by 7. 3600 is not divisible by 7. 300. 300 is divisible by 100. 3600 is divisible by 100. 1680 is not divisible by 100. Only option pending is 240. I hope the idea is clear. Next. HCF of 750, 6300, 18900. 180 is incorrect because 180 is 9 into 20. 180 is divisible by 9. 6300 is divisible by 9. 18900 also is divisible by 9. 750 is not divisible by 9. 180 is out. 170 is 17 into 10. 17 into 10. 750 is 750 divisible by 17? No. So it cannot be 170. 210 is nothing but 7 into 30. 7 into 30. Answer is divisible by 7. 6300 is divisible by 7. 18900 is divisible by 7. But it is not divisible by 750. 750 is not divisible by 7. 180 is out, 210 is out, 170 is out. What is the final option left? 150. 150. You can check it out. 150 is nothing but 25 into 2 into 3. Answer will have 2 because this is an even number, even number, even number. HCF of any even number is an even number. So answer will be 2. Answer will be 3 because 750 is divisible by 3, 6300 is divisible by 3, 18900 is divisible by 3. So answer is also divisible by 25. Excellent slide, sir. This slide covers all the questions how to use answer options. We have discussed how to use the lowest number in the given series, find the HCF. But sometimes it is becoming lengthy and these elimination based approach based problems uses a divisibility rule for the given numbers. This uses divisibility rule for the given numbers. This uses divisibility rule for the given numbers. These are the concepts. HCF of any two even numbers is an even number. HCF of any two odd numbers is an odd number. HCF of any two numbers which are divisible by k. Answer also is divisible by k. Idea clear? Extremely important slide. Extremely important slide. First we have discussed the definition of HCF. Then we have discussed how to find the HCF of a given numbers using the lowest number as the point of reference. If lowest number divides every other number, lowest number is called as a factor. If the lowest number is not dividing every other number, we will take the factors of the lowest number and we check what is the highest among the factors which will divide every other number. That's point number 2. Point number 3, we will use elimination based approach. We will use elimination based approach. I hope it is clear.
Press the bell icon on the YouTube app and never miss another update.
Now, minimum difference method. Minimum difference method. Before we solve this problem, let us take the concept. Another way to find out the HCF. Concept. HCF of any two numbers, not only two, you can take more than two. HCF of any two numbers. Answer is an element. Answer is an element in the set factor of B minus A. Please write down this concept. HCF of any two numbers. HCF of any two numbers. Answer is an element. Answer is an element in the set factor of B minus A. HCF of any two numbers. Answer is an element in the set factor of B minus A. For example, HCF of 15, 25. HCF of 15, 25. What is he saying? HCF of any two numbers is an element in the set factor of B minus A. Factor of B minus A. What is the factor of 25 minus 15? 10. What are the factors of 10? Factors of 10 are 1, 2, 5 and 10. He is telling that the HCF of 15, 25 is an element in the set 1, 2, 5, 10. Is an element in the set 1, 2, 5, 10. Is an element in the set 1, 2, 5, 10. HCF of any two numbers is an element in the set. HCF of any two numbers is an element in the set factor of B minus A. Factor of B minus A. Now if you see here, 15 is an odd number. 15 is an odd number. 25 is an odd number. Already we discussed HCF of any number of odd numbers. HCF of any number of odd numbers. Answer will be an odd number. HCF of any number of odd numbers will be an odd number. So answer cannot be 2. Answer cannot be 10. It cannot be 2 and 10. Are you all with me, sir? Right? Answer, because if a number is not divisible by 2, how can it be divisible by 10? 5. Does 15 divisible by 5? Yes. Is 25 divisible by 5? Yes. So what is the answer for this question? 5. Is 5 an element? Is an element is in the set 1, 2, 5, 10? Yes. HCF of any two numbers. HCF of any two numbers is an element in the set factor of B minus A. Extremely important first concept. HCF of any two numbers is an element in the set factor of B minus A. Why it should be a factor of B minus A? I took an example to show how it can be an element in the set factor of B minus A. How it can be an element in the set factor of B minus A. Right. Second one. HCF is always the minimum difference. Minimum difference factor. HCF is always the minimum difference for a given number factor. Take the minimum difference for a given numbers and take the factor. HCF of any numbers. HCF, the whatever the value that we are getting it in HCF, that HCF is nothing but a factor in the set minimum difference for a given numbers. You take the minimum difference for a given numbers, answer will be a factor among the given set. Answer will be a factor among the given set. Answer will be a factor among the given set. Now I will try doing this problem in the minimum difference method. Now I will do this problem in method 1 and method 2. Method 1 and method 2. Method 2, what is that we discussed? HCF of any two numbers, it is an element in the set factor of b minus a. Factor of b minus a. 32 minus 18 is 14. Answer is an element in the factor of 14. What are the factors of 14? 1, 2, 7 and 14. These are the factors of 14. HCF of any two even numbers will be an even number. So 1 anyway, 1 will divide every other number. 7 is out. 7 is out. Are you all with me, right, sir? 7 is out. If 7 is out, obviously 14 will be out. 7 is out, 14 will be out, 1 is out. Answer is 2. Answer is 2. So, HCF of any two numbers, HCF of any two numbers, answer is an element in the set factor of b minus a. Factor of 32 minus 18 is 14. What are the factors of 14? 1, 2, 7, 14. HCF of any two even number should be an even number. So, 1 and 7 is out. If a number is not divisible by 7, how can it be divisible by 14? 7 is out, 14 is out, 1 is out. Answer is 2. This is by using method 2. What is method 1? Take the lowest number, 18. Does 18 divide 32? No. Take all the factors of 18. 1, 2, 3, 6, 9, 18. Highest among this factor will be the answer. 18 will divide 18, but 18 does not divide 32. 9 will divide 18. 32 is not divisible by 32. 6 will divide 18. 32 is not divisible by 6. 3 will divide 18, but 32 is not divisible by 3. 1 and 2. So 2 will divide 18, 2 will divide 32. Answer is nothing but 2. Are you all with me? Both the methods it has given the same answer. Both the methods it has given the same answer. HCF of any two numbers. 1 is an HCF of any two numbers. Answer is an element. Answer is an element in the set factor of b minus a. Answer is an element in the set factor of b minus a. So if I take the difference 32 and 18, different factor of 14. What are the factors of 14? 1, 2, 7, 14. HCF of two even numbers is always an even number. Odd number 7 is out, odd number 1 is out. If a number is not divisible by 7, how can it be divisible by 14? So only option left is 2. If I use the traditional method, 18 does not divide 32. So take all the factors. 1, 2, 3, 6, 9, 18. 32 is not divisible by 18. 32 is not divisible by 9. 32 is not divisible by 6. 32 is not divisible by 3. So 1 and 2, highest is 2. Obviously it will be 2 because HCF of any two even numbers will be an even number. Idea clear? This is the first concept. Minimum difference method. Minimum difference method. Now method 2. Now second problem. Method 1. If you see the method 1, you have to take all the factors of 362 in this case. Am I right? All the factors of 362 you have to take, which will be a lengthy process. Which will be a lengthy process. All the factors of 362 will be a lengthy process. Now see here. Now we will use the minimum difference method. Minimum difference method will be the best method to solve few problems, right? Like second one. 362, 384, 478, 354. You don't need to take the factors of the lowest number. Another is, what is the thing? HCF is nothing but an element in the set. It is a factor of minimum difference for a given numbers. Minimum difference we have to do. 384, 362. Difference is 18. 362 478. 362 plus 38 is 400. 400 plus 478. 78 plus 38, which is 116. 362 with 354, 8. Minimum difference. Minimum difference. See here, by using this concept, instead of taking the factor of 362, I will just take the factor of 8. What are the factors of 8? 1, 2, 4, 8. 1, 2, 4, 8. Are you all with me? You can reduce the number of steps in this question if you know this logic. So difference is 8. Now if you see, HCF of all even should be an even number. Now if you see, let me see if it is divisible by 8. What is the divisibility rule of 8? Last 3 digits should be divisible by 8. 8 4s are 32, 42. 8 5s are 40. It is not divisible by 8. All the numbers are there divisible by 4. Divisibility rule of 4 is last 2 digits should be divisible by 4. 54 is not divisible by 4. So all are even number. HCF of even numbers is an even number. So answer for this question is 2. Answer for this question is 2. I hope the idea is clear. Either you can use method 1 or method 2. In the second example, you will have a complete clarity. Instead of taking the factors of the lowest number, you can take the factor of the minimum difference between two numbers. 362, 354. Minimum difference is nothing but 8. So answer is nothing but the factor of the lowest difference. 362, 354. Lowest difference is nothing but 8. Still we will solve more and more problems so that you will get a clarity.
You can learn any subject, anywhere, any place and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.